Assalamualaikum warahmatullahi wabarakatuh. Here we will explain about dynamic programming to determine the optimal route from Bukittinggi to Lampung. The background: Fathir, a student from Bukittinggi, West Sumatra, plans to travel to the city of Lampung after the holidays, as he wants to return to his college activities. Fathir needs to pick up two of his friends, Dhemas and Aghisa, who are in central Lampung. This journey becomes even more complicated considering the condition of West Sumatra following a natural disaster, which could damage road infrastructure and slow down travel. For this reason, Fathir needs to plan the best route, taking into account rest points such as Jambi, Lubuk Linggau, Lubuk Pinang, Manggala, Muara Enim, and Lahat. On the other hand, this is the disaster that occur must also be considered in the planning, especially to avoid affected or disaster-prone roads. So, based on this background, the main problem in this study arises, namely how to determine the most optimal travel route from Bukittinggi to the University of Lampung while still passing through the two predetermined pickup points. This problem includes how to model the journey in the form of a graph, how to calculate the total distance of each route alternative, and how to systematically select the route with the minimum distance. Therefore, a method is needed that can evaluate all route alternatives and produce an optimal solution, which is by using dynamic programming. What is dynamic programming? Dynamic programming is an optimization method that solves problems by breaking them down into several interrelated stages. Each stage is solved optimally to determine the best overall solution. This method is suitable for determining travel routes because each city can be considered a state and moving between cities as a stage of the journey. With dynamic programming, all route alternatives can be compared to obtain the path with minimum total distance. The purpose of the study is to determine the most optimal travel route from Bukittinggi to the University of Lampung while still passing through to predetermine pickup points. The optimal route in question is the ones with the minimum total distance. Furthermore, this study aims to apply the dynamic programming method as a systematic approach to evaluate all possible travel route alternatives, ensuring that the resulting route decisions are efficient and overall optimal. Data and information travel. The data in this study consists of intercity distance data curated during the journey from Bukittinggi to the University of Lampung. This data includes distance from the starting point to connecting cities, distance between connecting cities, as well as distance to pickup points and the final destination. This distance data is raw and obtained from mapping sources and travel estimate. The data is used as cost values in the dynamic programming calculating process. Okay, the information was obtained from processing distance data using the dynamic programming method. This information shows the total distance of each route alternative as well as which path has the minimum distance. Based on the information generated, the most optimal travel route from Bukittinggi to the University of Lampung can be determined while still passing through the two predetermined pickup points. Model dynamic programming. The travel problem from Bukittinggi to Lampung University is modeled using the dynamic programming method by dividing the journey into several stages. Each stage represents the move from one city to the next city. Each city bus is considered a state. The transition between states has a cost represented by the travel distance between cities. The goal of this model is to select the sequence of state transition that result in the minimum total travel distance to reach the final destination. Dynamic programming and calculation. The calculations start from the final stage, which is when the journey has reached the ultimate destination to the University of Lampung. At this stage, there are no further trips, so the cost function value is set to zero. Mathematically, it can be written as f g equals zero. This value serves as the basis for calculating the distance from the pick-up point to the University of Lampung in the previous stage. At this stage, the distance from the two pick-up points to the University of Lampung is calculated. This value will be used as the cost is in the previous stage. The calculation is as follows: Aghisa house to University of Lampung is 60 kilometer, and this value indicates that the minimum distance from the pickup points to the final destination has been determined and is ready to be used for the next stage of calculation. Okay, at this stage, the distance from the connecting cities Manggala, Muara Enim, and Lahat to the pickup point and then to the University of Lampung is calculated. Since pickup is mandatory, the route must pass through Agisa's house and Dhemas house. The minimum distance calculation used is Manggala to Aghisa House and University of Lampung is 16 kilometer. This function values show the minimum distance from each connecting city to the final destination. The final stage is calculated to the total travel distance from the starting point the Bukittinggi city, to the University of Lampung via the initial connecting city. The calculation is done by adding the distance from Bukittinggi to the destination with the minimum value from the previous stage. The calculating is as follows: Bukittinggi to Jambi 520 kilometer plus 510 kilometer equal 1030 kilometer. From all calculation, this road through Lubuk Linggau result in the shortest total distance, which is 1020 kilometer, and is therefore chosen as the optimal travel route. So Bukittinggi to Jambi. So Bukittinggi to Lubuk Linggau is the chosen as the optimal travel route. Based on all the dynamic programming calculation carried out from the last stage to the starting point, the travel route with the minimum total distance was obtained. The result optimal route is Bukittinggi to Jambi, Manggala. This is Jambi, not Lubuk Linggau. Manggala, Aghisa House, and Dhemas House 2, and then University of Lampung. This road was chosen because it has the smallest total distance compared to other alternative route, which is 1020 km. This result show that the optimal decision is obtained from the comprehensive evaluation of all stages of the journey, not just based on the shortest distance in a single segment. The result of analysis Based on the result of the modeling and calculation that have been carried out, it can be concluded that the dynamic programming method is effective for determining the optimal travel route from Bukittinggi to University of Lampung with several alternative paths and pickup points. Modeling the journey in the form of a graph and dividing it into several stages allow all routes alternatives to be evaluated systematically. The calculation results show that the route through Lublinga Jambi procedure is the minimum total distance, which is 1020 km, and is therefore chosen as the optimal route. Okay, thank you to those of you who have watched until the end. Sorry if there are any mistakes in my words. We will end the presentation. Assalamualaikum warahmatullahi wabarakatuh.